Hey guys, in this video we're going to talk about samples. Sometimes populations that we are interested in studying are just too large to try to summarize all of the data. Or sometimes the populations are so large we cannot possibly collect data from the entire population. So for example, if we wanted to make an inference or a prediction about the entire US population, for example, if we wanted to try to predict who they were going to elect as our next president, or if we wanted to find out what most Americans like to do for fun. The population is just too large, and there's no way we could possibly gather information from every member of the population. Or even the city of Spencer, if we wanted to find out something about everybody that lives in Spencer, it's just too expensive or too time consuming to gather information from everybody in the whole city. Or maybe we want to find out how many smartphones that are produced in a factory in one day are defective. Well, we can't take the time to test every single phone. That population is just too large. So what we need are called samples. So when we talk about a population, we're talking about the entire group we're interested in studying in statistics. So I had just mentioned a few examples of populations. The entire city of Spencer, everybody that lives in the US, everybody in Spencer Middle School, or all of the cell phones produced in a factory in one day. It's just whatever the entire group we're interested in drawing a conclusion about, that's our population. And a sample is just simply a part of that population. And a sample can tell us a lot about a population without collecting data from the whole population. So think of a pizza. If you were blindfolded and I had this pizza in front of you, do you have to eat the whole pizza to know what kind of pizza it is? I'm sure you're probably thinking, yes, because I would like to eat that whole pizza. But you really don't need to eat the whole pizza to know what kind of pizza it is. If you just take a few bites from it, you can probably get a good idea of what the entire pizza is like. Okay? So samples can tell us a lot about the entire population. We don't need to know information from the entire population to know what the whole population is like. However, not all samples are good. So what makes a good sample? Good samples have to be representative of the larger population. So go back to the pizza example. What if I just took a sample from just the crust? That's not going to tell me much about the what kind of pizza it is, because the crust isn't representative of the whole population. It's just a small part. Also, samples have to be selected at random or without preference, and they have to be large enough to provide accurate data. So again, I couldn't just take maybe a crumb of that pizza and to be able to tell what kind of pizza it is. I have to have a large enough sample to know what the whole pizza was like. So also, an unbiased sample is a sample that is representative of the larger population and selected at random. So good samples are called unbiased samples. And we said that they had to be selected at random. And random means that they're selected without preference, or every item in the population has an equal chance of being selected. Every part of that pizza would have to have a chance to be selected for it to be random. And if not, they're called biased samples. And a biased sample is a sample that is not representative of the population, or a sample where every member of the population didn't have a chance of being selected. So how do we get a good sample? Well, there are several ways to get a good sample. We're going to talk about 3 of them. And ways to get unbiased samples, again, these are going to be random samples, and there are 3 types of random samples. There's a simple random sample where each item or person in a population is just as likely to be chosen as any other. So an example, 30 student ID numbers are randomly selected by a computer. So just random draw from the population. Everybody has a chance of being selected, and the sample was just chosen randomly. Another way to do it would be a stratified random sample. And this is when you take the population and you divide it into similar non-overlapping groups. So you cut the whole population into groups, and then you pick a simple random sample from each group. So the example is a population of election districts can be separated into urban, suburban, and rural strata. So you divide the whole population into those three subgroups: urban, suburban, and rural, and then you randomly pick people from each of those subgroups. And then lastly, we have a systematic random sample, and the items or people are selected according to a specific time or item interval. So every 20 minutes a customer is chosen, or every 10th customer in line is chosen. It follows a rule. So we define a rule, and that rule tells us how to select members from the population. And how we collect the sample determines whether it is good or not. So just to clarify these types of samples, I'm going to go back to our pizza. So in the first picture, we have a simple random sample. And here I just randomly put circles or places where I would take a sample. So I select 10 random places on the pizza to sample. So if you could imagine taking a bite at all of those locations, that'd probably give us a pretty good idea of what kind of pizza we're talking about. The stratified random sample would be like dividing the pizza into equal slices. So this pizza is cut into 8 equal slices, and notice I took one sample, a random spot on every slice. So that's what makes it different from a simple random sample, is first we divide it into equal groups, and then we select a random sample from each of those groups. And then finally, the systematic random sample would be following a rule, where a rule determines where my sample is taken from. And so I have a grid where every 3 inches I take a sample. So I measure on the pizza, and every 3 inches, that's where I take my sample from in a grid. So you can see the difference between these 3 different types of random samples and ways to get samples. And hopefully you can see that all 3 of them would give us a really good idea of what kind of pizza we're talking about. So again, we don't need to eat the whole pizza to know what kind of pizza it is. Samples are very powerful, but they have to be collected in the right way. Well, what happens if we collect them in the wrong way? How can you collect a sample incorrectly and get a biased sample? Well, there's a lot of ways to get bias in your samples, but we're only going to talk about 2 of them. One way to get a bad sample would be a convenience sample, and this is just members of the population that are easily accessed. So it's kind of a lazy way to collect data. Just whatever the first members of the population you come across, that's just what you pick. And an example would be the first 10 students in the cafeteria line. Well, not everybody in the population had a chance, as only the first 10 people were chosen. Also, voluntary response sample. This involves those who want to or can participate in the sampling. And the example is the principal sent an email to graduating seniors asking them where to hold commencement. Seniors are asked to vote through an online poll. So only people that want to give their input would be in your sample. So not everybody had a chance or an equal chance of being in that sample. So examples, convenience samples. I want to know what everyone's favorite lunch is in the middle school. So the middle school is my population, and I ask 10 people that I sit with at lunch. And that's a convenient sample because they're just there, they're easily accessed, they're my friends. That's not a good sample though, because not everybody in the middle school had a chance of being selected because that's my population. So only people that eat lunch with me, probably in the same grade as me, have a chance to be selected. So everybody else that's not in the same grade as me was excluded from that sample. Also, I want to know what the most popular restaurant is in Spencer. So I go to Sports Page and ask the first 25 people I see. That's a convenient sample because they're all located in one place and they're the first people that I see. Well, obviously you can tell that you're not going to get very good data from that sample because if they're at Sports Page, they're probably more likely to say that Sports Page is their favorite restaurant. They won't all say that, but they're more likely to. Examples of voluntary response samples. I want to know if a hotel I will be staying at is good, so I check the online reviews. Now, online reviews are excellent examples of voluntary response samples because what type of people are going to choose to fill out an online review for a hotel? Well, it's going to be one of 2 groups most likely. It's going to be the people that really, really love the hotel or really, really hated the hotel. If your stay at the hotel was just average or what you expected, you're probably not going to take time to fill out an online review. So the data collected from online reviews is not really that reliable. Or also, I want to know if the Super Glitter Pony skateboard I want on Amazon is good, so I read the customer reviews there. So you can see I've got images of actual customer reviews, and one of them shows overwhelmingly 5-star votes out of over 2,000 reviews, and it's just people that really liked it, and they're going to take the time to do a review. Or in the other image, you'll see that there are mostly 5-star, 4-star, or 1-star. So it's one extreme or the other. And if you just go to Amazon and check customer reviews, their customer reviews are going to typically look like this, where they're either going to be mostly positive, mostly negative, or an even split of positive and negative. Not many people take the time to get on Amazon and give a 3-star review. So that is biased. Those are bad samples. We can't really do much with those. So how do we make predictions with samples? If you want to make a prediction or a conclusion about a population based on a sample, the sample must not be biased. We cannot have a bad sample. It has to be an unbiased sample. So we have to collect it in one of those 3 random ways. If your sample is biased, you cannot use the sample to make a valid prediction or a conclusion about the population. Bad sample equals bad data. So if your sample is collected incorrectly, you might as well just throw it away because it's useless. There's nothing we can do with that data because it does not represent the population. So let's take a look at some example scenarios here, and we need to decide, are these biased or are these unbiased? Are they good samples or are they bad samples? So to determine the types of music a concert hall's customers like best, all the people attending a country music concert are surveyed. Identify the sample as biased or unbiased and describe its type and explain your reasoning. Well, first we want to look at who is our population. Who are we trying to draw a conclusion about? And that is a concert hall's customers. We want to draw a conclusion about all of the concert hall's customers. And then who is our sample? Our sample are the people attending a country music concert. That's who we collected our survey from. So is that sample representative of the whole population? If your answer is no, then this is biased. If it's yes, then it's unbiased. Well, hopefully you can identify that this is not a good sample. This is biased. This is a bad sample. We can't draw a conclusion about all of the concert hall's customers simply from a sample of country music fans. Why? Because what do you think the country music fans are going to say is their favorite type of music? Probably country. So this is a bad sample. And what method was used to get this? This was a convenience sample. Everybody was all in one place, all at the same time. So we just went to the country music concert and got our sample. So this is bad. There's nothing we can do with that data. Bad data, bad conclusions. Next one, to determine which passengers' carry-on bags are to be inspected, every 8th person to check in will have his or her bags inspected. And we want to identify this as biased or unbiased and describe its type. So we're always looking for who's the population and what's the sample. Well, who's the population that we're talking about here? We're talking about passengers, all the passengers on this plane or train or whatever it is. And who is the sample? How did we collect our sample? We took every 8th person. And that is a random sample. So this is unbiased. This is a good sample. And what type of method did they use? Well, they used a rule. And when you use a rule, every 8th person, that's called a systematic random sample. And since the data was collected in a random way, in a valid way, we can use this sample to make a conclusion or prediction about all of the passengers on this plane. Next one, of the 2,000 watches made, the manufacturer tests the first 15 watches produced for defects. Of the watches, 3 were defective. Is this sampling method valid? If so, about how many of the 2,000 were defective? So again, What's the population? What are we interested in trying to make a conclusion about? It's the 2,000 watches that were made that day. And what is our sample? It was the first 15 watches produced. So is this a good sample or is this a bad sample? Biased or unbiased? This is biased. That is not a good sample. What type of sample was it? Again, this was a convenience sample because it was just the first 15. First 15 watches that we took off the line, those are the ones we're going to use. So can we use that data that we collected from that sample? 3 out of the 15 were defective. So can we use that to make a prediction about the rest of the 2,000? No, we can't. There's nothing more we can do because this is just a bad sample. So we can't actually draw any valid conclusions or make any valid predictions about our populations based on that sample. Next one. After finishing their meal, every 5th person that left a restaurant was surveyed about whether they ordered dessert after their meals. Out of 20 people, 12 said yes. Is this sampling method valid? If so, about how many of the 100 people who had dinner at the restaurant ate dessert? So again, who's the population? Who are we interested in studying? We're interested in the 100 people who had dinner at the restaurant. That's our population. How did we get our sample? Who's the sample? Every 5th person that left the restaurant was our sample. So was this a good sampling method or a bad sampling method? Is this biased or is this unbiased? This followed a rule. Every 5th person that left the restaurant. So this is unbiased. This is actually a good sample. And this was, again, a systematic random sample. And since it's a good sample, now we can use it. We can use it to draw a conclusion about our population. This was valid. I forgot they asked us to tell if it was valid or not. That's valid. It's unbiased. It was a systematic random sample. So now I can use the data that I got from the sample. And the data was 12 out of the 20 from my sample said that they had dessert. So this is the data from the sample. And we can actually apply this to the whole population. How many out of the 100 people that had dinner at the restaurant would have had dessert? We can use our sample to predict about how many people in the whole population had dessert. So if you solve this proportion, you get x equals 60. So we could conclude with some degree of confidence that about 60 people had dessert. Good sample, good data, we can draw conclusions from it. So, in summary, samples can tell us a lot about a population, but they must be good samples, and we call good samples unbiased. There are ways of getting unbiased samples using random selection. We can use the simple random sample, stratified random sample, or systematic random sample. There are ways of getting biased samples or bad samples, and those are convenience samples or voluntary response samples. And if you have a bad sample, it is not valid, and you cannot make any inferences or predictions about the population with it. But if you have a good sample, it is valid, and you can make an inference or a prediction about the population with it.